Okay, thank you guys for joining and hanging in with us here. I just wanted to, not a limited time, so we're just going to be touching on a few items today. Certainly happy to answer any other questions. We have a lot else going on, but just wanted to highlight a few of the items. The first one is we've talked a lot about this response index using the green seeker NDVI to identify when you need a top dress N application. It can be very difficult to eyeball if you really need one or not. And very quickly, the response index is a ratio of an area in the field that you've added extra nitrogen to, so you know it's not nitrogen limited, and then divided by the field NDVI. And that would give you, if you divide those two numbers, a response index. The bigger this number will go down to 1.0, and the bigger the number is, the more deficient your field is. So we've developed, in the past, we sort of said, well, 1.1 response index is really where you want to be applying your top dress nitrogen. If it's 1.1 or higher, that's when you need to do that. So we just decided here to provide a little bit more information behind that in this graph. And so this is the response index along the x-axis here with increasing nitrogen deficiency as you go to the right. On the left, this is the average yield response we saw to a top dress N application. And on this other axis is the probability of just getting a positive response. So you'll see that at a 1, you have very little chance. You have about a 50-50 chance of getting any kind of positive yield response here. And the yield response, if you do get it, is probably going to be very little. If you move out to 1.09, you have about a 95% chance of a positive yield response, and your yield response is going to be around 200 pounds an acre. And I think that's kind of around the break-even point, just considering the cost of fertilizers and flying on a top dress. It's going to be about 2 sack yield increase that you'd want at a minimum. So we're suggesting a 1.09 response index as a good one to go. This data was developed using a top dress N rate of 30 pounds of N per acre. We're developing a fact sheet on this that will provide more information. The second area I wanted to quickly cover was lodging in M105 and M206. We started this research because a lot of growers were saying and kind of moving away from M105 because of lodging. They felt that it really lodged a lot easier than other varieties. But it's a really good variety in terms of yield. It's also our earliest variety. And so we set up a test in 2020 to sort of quantify lodging across a lot of different N rates and to see if maybe splitting the nitrogen, between a pre-plant and a top dress might help reduce lodging if it is occurring. So we had treatments of 120 up to 210. We had those high-end treatments just to ensure we would get lodging. And then in each of those, we added top dress nitrogen. Before I go on to that, one interesting thing about these varieties that we noticed right away is that M206 was much more susceptible to serrano damage than M105. And you can see that very clearly in this picture, the yellow being all of the M206 and the green being that. So just something that you can keep in mind when you're using these varieties. But here's the main point here. And given the time, I just really want to focus right here on the lodging because we didn't see any yield differences. among these N rates or between the two varieties. But this is canopy height. So this is really our lodging indicator along this y-axis. And so all we did was measure the height from the soil to the very top of the canopy. So if it's up at 30 inches, that's pretty much standing rice. When it gets down over here into, you're talking 15, 16, 17 inches, that rice is pretty close to the ground. We took these measurements probably 4 or 5 days before we actually harvested. And by that harvest time, it had actually all dropped even a little bit more. I guess the main thing that we saw was kind of a surprise to us is M206 actually in this study lodged significantly more than M105. And you can see that across the board, across all of the N rates. Significantly more lodging. We did see the M206 on average was about 1/2 inch to 1.5 inches taller than M105, which may have caused a little bit of that. But certainly, this was not necessarily what we expect. The other thing that we saw was we didn't see applying all of the N up front. Some growers felt that sort of increases the propensity to lodge. We didn't see that. In fact, generally, we saw the opposite. And I'll just give you an example here where it's quite clear at this 180 N rate. M206 here got a split application. So 30 of this 180 was applied at top dress and 150 at pre-plant. And it lodged more than what we applied all 180 at pre-plant. And we saw the same thing at the same N rate with M105. But clearly, sometimes it seemed like, well, maybe there was a little less lodging here with a split, and down here at the end, there's really very little difference. So statistically, nothing really came of that. On average, it seemed to tend to lodge more with a split application, but this is something we're gonna look at again here in the future. I think it's really important to understand what's going on. The other thing I just wanted to talk about was some work we're doing comparing different nitrogen sources really for application after flooding. This occurs when, maybe in a year like this year, the aqua is not available and you need to flood, or rain causes, rain's coming and you need to flood the field quickly. What are your options then in terms of nitrogen management? So we had a lot of different treatments, and I'm not going to go over individually each of these, but we had ammonium sulfate, urea, and various enhanced efficiency fertilizers applied right after planting. So this was into a flooded field. We had the same group of fertilizers applied 2 weeks after planting. And then we had split applications of ammonium sulfate and urea. And these were split at 2, 4, 6, and 8 weeks after planting at a 20, 30, 30, 20 ratio. All the nitrogen was 135 pounds N per acre. We had a control where no fertilizer was applied. The enhanced efficiency fertilizers were Super U and Anvil. These are both by Koch Agronomics. Super U is a urease and nitrification inhibitor, while Anvil is a urease inhibitor. And then we had a coated urea, which delays the availability by a resin coat around the urea granules, and that's by ICL Agrocoat. So very quickly, just wanted to show the results here. So what we see is, in general, day after planting, the later you applied it, the higher the yield. So the yields are here and the treatments are here. The control here, about 40 sac yields. And on average, I've just kind of grouped these day after planting, about 90 sacks you delay applying all of that nitrogen, and again, this is a whole slug of nitrogen out at one time, you're getting 98 sacks. And then if you split it, like we had talked about, you're getting about 10.1 or 101 sacks, sorry. So clearly, as you're delaying the application or splitting the application, you're getting better yields. You're applying nitrogen closer and closer to when the plant needs it. When you're applying it all up front, nitrogen can get lost to the environment in so many different ways. And it's doing that in these situations. So we also saw a lot of growers as well as ammonium sulfate better than urea. Across the board, we saw these things compare very similarly. I've kind of put circles around the two, ammonium sulfate and urea treatments. And you can see there's really, there's certainly no significant difference and no trend even of one being better than the other. So they perform very well. Again, we don't think there's any sulfate limitations out at this site at the RES, so that's not a surprise. We also saw a couple of the enhanced efficiency fertilizers showing some promise. In this case, Anvil applied right after planting looked pretty good, significantly higher than some of these others. And then this ICL product out over here 2 weeks after planting, both of these perform very similar to the split application. So we're going to be repeating this study in 2021. This year, we're looking for a grower probably to do this on, as well as repeating it at the station.
Bruce, you have 3 minutes.
In wrapping up, I just wanted to highlight where we can get more of this information. I think Luis had already talked about this. You can go to our website, hit the fact sheet button, and we've developed a number of fact sheets related to nutrient management. And there's a lot more on there related to some of the diseases and pests that Luis had managed. So these are kind of bite-sized. These are 2-pagers with just the essential information on a particular topic. So we've got nutrients in rice grain and straw at harvest, optimal and critical nutrient concentrations in rice tissues if you're testing tissues, a good fact sheet to have, and then how to manage potassium and phosphorus in our rice fields. And we're coming up with more all the time. These are fairly new. Also, if you have any ideas on some suggestions on some ideas for a topic, please let us know. And with that, I'd like to thank the Rice Research Board and also some great help I have with students in my lab and our department. So thank you, and I'm not sure if I have time for questions.